Now, what else can we do with the 3D model? Well, what about analytics, right? One of the big advantages of OpenBridge Designer is the combination of creating the 3D model and that same model be to be used by the analytical solutions. This time, the analytical solutions that we connect are the internal Bentley solutions: Liebridge Concrete, Liebridge Steel, and RM Bridge. So, depending on the type of bridge that we have modeled in OpenBridge Modeler, we need to transfer them for pre-stress girder to Liebridge Concrete, steel bridges, Liebridge Steel, and if we need more complex analysis, stage construction analysis, time history, or advanced seismic or wind design, well, RM Bridge is the solution that we need to transfer our big model to these analytical solutions as well, right? So, for example, if we go a pre-stress girder bridge, right? So it's designed to small and medium span concrete bridges, right? It's all parametric design, and we can transfer the information between the model to analytics, the analytics to model, right? It includes the one of the latest LRFD codes. At this time, we are on the ninth edition. We know that the 10th edition is coming as well, right? This 3D model that we have created becomes an analytical model and is ready to do the analysis, calculate the number of strands needed, the reinforcement needed for the piers. And the way to transfer that information is quite simple. As we have finished our 3D concrete model, it's just a matter of saying, I just need to send it to Liebridge Concrete. So it would just be sent to it. This physical model will be converted with certain assumptions, right, to become an analytical model. So then after that, we are ready to perform all the design that is needed. And now, if something needs to be changed because of the analytics, right? Maybe change the size of the beams that we use, or need to change the size of the columns or the footings. So then we can do it here and send it to the 3D model, or we can come back to the 3D model, make the necessary fixes, and then send it again to LibReg and update the analytical model and proceed with the calculation. So all that information is being sent. It will do, of course, the cell weight analysis, light load analysis. You can customize, for example, the type of trucks that we use. Again, LRFD code uses HL93, but different states, different countries have their own trucks, their own type of materials for rebar, for strands, and all of that. So all of that could be included or customized inside LibReg Concrete. In general, all the analytical solutions, concrete, LibReg Steel, and RM Bridge, could be customized, make it according to your standards. So we perform the design. Of course, depending on the concrete, it will run the different limit states that the LRFD code requires. And we can just set up the strands, or we can allow the software to design the number of strands needed for every beam, or just generate one and just copy the rest and see if the design passes or not, right? Again, to promote the standardization. Uh, so all this design then will be sent to all the other beams, and then we will have, of course, our design, not only for the strands, but also the stirrups could be designed as well in Libris concrete if we're doing, of course, concrete bridges, right? So the next step after that will be not only to we can change, for example, maybe we need to change the beam size. So just to illustrate the concept, changing the beam size in the analytical solution, right? But I want this change that I made to be carried over to the 3D model. Actually, the 3D model, the beam model, is the single source of truth, as we call it. This is the repository of all the information, not the analytics. The analytic is just, let's call it our calculator, or to say something, right? So I'm changing the beam sizes, so maybe on a couple of beams or the entire span if I need to, but then I want to update the 3D model with the changes that I just made. So I made a change, for example, continue with the design passes, so I'm good now. So I need to update my 3D model, calculate the new loads, do the analysis, and do the design. So again, like any design, it's an iterative process until I find the right solution, optimize maybe a solutions as the software allows me to do as many iterations that I need, right? So update my calculations, update my model so I can review these changes into the analytical model just to see, right? Oh, notice the beam changes there. So as you can see, my geometry in the analytical model has also changed. So the first span, as I did, is of different beam size. And I want, of course, to update or incorporate the changes into my beam model. So let's do that. I just say synchronize. So send it to OBM. It will create internally what is called an XML file, so a transfer file. Okay. Remember, this is not a change in format. It's a transfer of information. The file that we use is a free format file called XML, XML type. So we do that, and that is the file that OpenBridge modeler, right? Our model is going to read to update the 3D model. So that is done. Now I can go back to my 3D model and say, bring the information, right? Update, read that transfer file that I just created with the analytical solution, right? And then it will inform you what changes are being detected. Again, depend changes between the model that is right now against the model that I have changed on the analytics. I accept all the changes, so then the software will just update. In this case, right, it was the first span, the beam sizes. So it will make that update uh, fairly automatic, adjust the piers, adjust the supports, and then I can proceed maybe with the plans production, with requesting reports for the new elevations that are being encountered. So all that options could be set up if I do this on a pre-stress curve bridge. Now, that same transfer of information is being done if I use leverage steel. That's what we're going to be using later here as well. So again, it's designed for small to medium span steel bridges. It has an integrated database as well as all the different elements that are coming from OpenBridge, all the different cross frames, plate sizes, and all of that are transferred directly to LibRich Steel. It has, of course, the latest are LRFD codes. It also does the same as LibRich Concrete. If I forgot to mention, a low rating analysis for the bridge that you are designing at that time. And the transfer is almost the same, right? As I finish my steel bridge, I just say transfer this to LibRich Steel. So it will do the same, create a transfer file, and then it will just open LibRich Steel and incorporate the file right there. And then you can proceed with the design, all the design checks, uh, with extra reporting capabilities, as we're going to see later when we do some design, but the transfer it's is there with all the options that we have added. Right here, if we need to make some changes, it can be done. Certainly limited though, because for example, with the cross frames, since they are placed with great detail, and this is only an analytical model, I will recommend to do all these changes that you need in OpenBridge Modeler. But then after you finish the design, we can do line girder, gradient analysis, and on the latest versions, we can also do finite element analysis. In this case, you're seeing an high girder bridge, but we can also do steel tops if you need to. So as you run the analysis, it's a different look on what lip bridge concrete look. This is, I would say, a more modern look. We're conserving the other one because of legacy purposes. But then this is a newer development. I mean, in a sense, right? This is more than, I would say, what, 10 years off or more than that. Even that, well, lip bridge concrete is way older than that, right? But then this is one of the newest solutions that we have developed, and it already has some years, but it allows us to uh, put it in a more modern look, I would say. Anyhow, we have the options here to report. The reporting as well is done in greater detail, checking every element of the bridge. Uh, so, and create, of course, a different type of report since it's a Canva report that the bridge still needs. Now, as I mentioned before, if it needs a more advanced solution, so then we're talking about RM bridge for all the other bridges that we don't do with lip bridge concrete, lip bridge steel, right? So suspension bridges, trusses, any kind of construction methodology, span by span, balance cantilever, advanced shoring, incremental launching, and it's more of a software for international use, I would say. Uh, but again, if you have a more complex design that needs really complex analysis, so I'm calling advanced seismic, wind analysis, stage construction analysis. So RM will be your software of choice as it has, advanced design capabilities as well as you can see, right? So with RM bridge, the transfer again it's almost the same. So we have a segmental bridge. So we just need to send it to RM bridge. The difference here is as the transfer is done, it will automatically perform an stability check. So again, remember we know all the properties of the bridge and the materials that it was used. So as it's transferred, it does a stability check and it does a preliminary seismic analysis. Again, it just generates the eigen modes or the modes of vibration of the bridge, right? So and it transfer as much as it can be that developed. So it also has the capabilities to do finite element analysis if you need to. But if you're going to check design codes, of course, beam analysis is needed. So it switches between beam analysis and finite element if you need to. And reporting as well for all the different forces, stresses, and checks that it needs to be done. Now, here the interoperability, I would say, is limited if you need to do any changes in the model, right? Because of a structural analysis, do it in OpenBridge. Don't do it in RM. What RM does at one point is all these tendons, for example, on a segmental bridge, they can transfer that to OpenBridge Modeler. However, again, structural changes, right? Do it in OpenBridge Modeler and not in RM Bridge. And then you can constantly be updating the document then. Okay. Now, to finalize the design, I mean, let me show you the example of New York. They was the ones that started with this many years ago, right? In which they were one of the first DOTs that, for the first time, they used the 3D model on all the information in DGN files for contract bidding. All that information, so they generate an I model, and the contractors just need to download the package, and all the information was in the files. It was no much paper documentation there. So boring logs, calculations, Excel spreadsheets that they may need it, and all the information regarding this project was in the DGN file or the iTwin file, right? So if you need, as you can see, there's different icons to extract the specific information there. So again, that was one of the first DOTs to do a contract bidding based on the 3D model. Stating that, thank you. We will proceed with the rest then.